Okay, here's a free response question from 2009 on acids and bases on this AP chemistry exam. The first question says, use the information below to answer part A, and what they've given you is a couple of Ka values for hypochlorous and hypobromic acid. The hypochlorous has a larger number, therefore it's a stronger acid, which is exactly what they're asking in part 1. Which of the two acids is stronger? The answer, once again, is hypochlorous because it has a higher Ka. That's all we need to do because they asked to justify it in terms of the Ka. Draw a Lewis diagram consistent with the acid, which for us is hypochlorous. That would be H bonded to, so pair of electrons, to oxygen. Oxygen has two lone pairs always, so I'd draw one above and below. Bonded to, meaning a pair of electrons, chlorine, with its three lone pairs. So a pair there, there, and there. And you should have a complete octet for both of those, and the two electrons needed for hydrogen. And there it is. Hypoiodous acid has the formula HOI. Predict what will be a stronger acid or a weaker acid than hypochlorous, and explain it in terms of bonding. Well, the numbers are getting smaller, so hypoiodous will probably be in the realm of 10 to the minus 10th. Therefore, it will be a weaker acid. The reason can be explained in terms of electronegativity. Chlorine is the most electronegative of the three. It's pulling electron density away from that bond, making it weaker. A weaker bond means more dissociation, means more ionic character, means a higher K sub A. So the iodous has the least strongly pulled away electrons, therefore more electron density, therefore stronger bond, therefore a weaker acid. That's a mouthful. They termed it this way. I'll just say HOI is a weaker acid than HOCl because the OH bond in HOI is stronger than the OH bond in HOCl. So that's clear. To be a stronger acid, you need a weaker bond because it dissociates more. The lower electronegativity, that's the electron drawing ability of I, compared with the chlorine, results in more electron density in that bonding region. That makes it a stronger bond. You could also explain it in terms of the conjugate base, but I didn't. Now it says write the equation for the reaction that occurs between hypochlorous acid and water. It should be donating a proton to water to make H3O+, or you could simply show it dissociating. So hypochlorous acid plus water donates that H+, leaving us with the conjugate base right there and H3O+, or just show it simply dissociating. Now finally we have a question about sodium hypochlorite. So we've got a 1.2 molar sodium hypochlorite solution, and they prepared it by dissolving it in water at 298 K. There's the hydrolysis reaction showing this acting as a Bronsted base, generating hydroxide ion in solution. It says write the equilibrium constant expression above. That's pretty easy, so it'll be these two products in square brackets, divided simply by the hypochlorite because water is a liquid and we omit solids and liquids. So there it is set up, and then they say go ahead and calculate the value of this hydrolysis reaction. Well, that's cute. It's K sub B. We do have K sub A from the last slide. K sub A times K sub B is equal to 10 to the minus 14th. So we rearrange and solve for K sub B. And there it is. See how they 10 to the minus 14th over the K sub A, meaning that your K sub B is 3.4 times 10 to the minus 7th. This must be needed for something. They say now calculate the value of hydroxide in the 1.2 molar solution at 298 K. Well, you could think of this in terms of an ice table, right? Because it's 1.2 molar, but as this thing proceeds, it's going to, the hypochlorite concentration is going down a little bit right there. We can call that 1.2 minus X. Cross off the minus X because we always do. And it's going to be going up by a value of X for each of these, because for every one of those that you lose, you gain one of those and one of those, giving us this number equals x squared over 1.2. Solve for x, and it's equal to 6.4 times 10 to the minus fourth molar. Since it's one of those values is hydroxide, that is the hydroxide ion concentration in moles per liter. And that's the 2009 AP Chemistry FRQ on acids and bases.